Yes, so my study assessed micropopulation and health in relation to land use and contaminated soils surrounding Alaskan lakes. Our test sites were Lake Hood, a passenger seaplane lake, one of the busiest in the world, and University Lake, a lake surrounded by land used for recreational activities such as kayaking and dog walking. Both of the lakes are located in Anchorage, Alaska, and samples were taken in July of this year. The sampling yielded 38 soil samples and 6 water samples, which have undergone the following analysis. For the water testing, the first test was pH. All of the samples came back roughly around 7 to 8, which is what we expected. The next test was calcium hardness and total hardness tests. The result for this test were greater than the sensitivity or detection limit for the testing kit being used, meaning the carbonate hardness and total hardness must be greater than the 200 ppm as CaCO3 limit, meaning the water is classified as hard water. The nitrogen test revealed excessive levels. The nitrogen test revealed some excessive levels in Lake Hood. However, there were moderate to no, sorry, the nitrogen test revealed no excessive levels in Lake Hood and some moderate to high levels in University Lake. A possible reason for these nitrate levels are the excessive use of fertilizer, as well as a high amount of dog feces in the area being washed into the lake. The phosphate test revealed low to moderate levels in Lake Hood, while there are negligible amounts in University Lake. For the soil testing, the graph represents a relationship between the nucleic acid concentration with the sites from each lake. Nucleic acid concentration will serve as our indicator for micropopulation, and I'll refer to it as NAC going forward. So for Lake Hood Site 1, it had the highest NAC concentration of 50.6 nanograms per microliter and the highest pH. The site had no seaplanes parked along the shoreline, and it was several yards off from the nearby road. Lake Hood Site 3 was the most industrial area of the 4 sites. It was by a parking hangar for planes, and the water had a visible sheen when the sample was taken. Site 3 also had the lowest NAC count, being 14.6 nanograms per microliter, which is very low. Lake Hood Site 2 fell somewhere in between Site 1 and Site 3, having seaplanes parked along the shoreline and a median NAC. Lake Hood Site 4 was a control site. The sample was taken in the woods approximately 15 meters from the shoreline, and the sample presented a high NAC, being 44.7 nanograms per microliter. Between these 4 samples, there does seem to be a correlation between NAC and the presence of seaplanes or human activity. Site 1 and Site 4, which had the lowest human activity, had the highest NAC, while Site 2 and Site 3 had the higher amounts of human activity and a lower NAC. The water pH at these sites also decreased as seaplane presence increased. On to University Lake. All of our University Lake samples had approximately the same NAC and pH, with Site 1 being the lowest. This makes sense because Site 1, when I visited, I saw that it had a lot of human activity because this was the kayak put-in spot, and the ground was very bare. There was no grass covering it. Site 2 and Site 3 of University Lake were visually similar with their human exposure levels and their NAC count. Lake Hood and University Lake are just 2 examples of how increasing human activity and shifting land use patterns can threaten environments in Alaska. Our future work for this project, will be microbial DNA sequencing, which will reveal specific microbes for a more in-depth analysis. We're going to be looking for hydrocarbon clastic bacteria and E. coli, which can confirm or deny some of our hypotheses. And our next steps will also be water pollution tests, including iron, sulfide, and ammonia tests to reveal more about the trends with NAC. Thank you so much.